welcome to the show. It's me, John Park. Welcome to John Park's workshop. Here we are. And that's the bleeps and bloops, and now on to the show, right? Hey, Noam Pedro in the chat over on YouTube. Thank you, the fresh soundscape. That is another Super Collider Lua Norns sketch that I'm running. I can unplug this and show you. On my little DIY Norns board called the Fates. It's a Raspberry Pi inside of there and a little DAC board with screen and stuff. And that's a super cool community donated Super Collider script that I'm running there. Well, let's see. What's happening, huh? We've got some great stuff to go over today. I'm really excited about the Circuit Playground Bluefruit. So I'm going to show you some stuff with that today. Really cool new board. And I'll talk about why I'm so excited about it in a little bit and show you some stuff in action. But first, let's go over some things. For example, did you know that we have a jobs board? And it's an entirely free jobs board. It's true. And if you, wow, that's a lot of me. How did I get all, here, let me get rid of that me. If you check it out, there's some interesting new positions that have cropped up on the jobs board from Crowd Supply. Here's one. They're looking for a community manager. Is that you? Are you the new community manager? Well, maybe you are. The position is up in Portland, Oregon. And there are actually some others. If you go back, there's a customer support coordinator, the community manager, a project manager, and a lead software engineer, all up at Crowd Supply. Very interesting. So why don't you go check that out? And if you're interested in posting a position, just create an account there or just have an Adafruit account. It's free. Free to use the job board. And you can also post your resume if you're looking to get some work. So that's the Adafruit jobs board. Now, this brings us to our coupon code of the day, and I was hungry when I chose this. So the coupon code for the day is pancakes, and it has nothing to do with the project or anything clever like that. It's just a word I like when I'm hungry. So if you go to the Adafruit store and you fill your cart up with good stuff, and you want to get 10% off, and who wouldn't, then go ahead and type that in, pancakes. That'll get you 10% off on the way out. That's good on everything except for gift certificates, software, and subscriptions. Now, since I said subscriptions, that reminds me that there is time to subscribe for the next AdaBox. AdaBox 14, it's just right around the corner. We have 45 days left and 7 hours, 56 minutes, and 14 seconds until it ships. So head on over there and subscribe. You can be the first person on your block to get the latest cool stuff if you sign up for AdaBox. What else have we got? What's over here? Oh, hey, how about a product of the week? So my product pick of the week this week is this ultra skinny NeoPixel strip. In fact, I have one right here because it's hard to believe how teeny and ultra skinny these are. I'm running, this is a 1/2 meter strip. There's 75 NeoPixels on that. It's pretty dense. And I have these running just off of a little trinket here, a trinket that I grafted some little terminal blocks onto. But these may just be the thing you're looking for your cosplay costume or prop or Halloween costume. They're so tiny, and they can do all the things NeoPixels can do because they are NeoPixels. These are the teeniest, most dense strips that we've done before. They also have a little adhesive on the back. It's a flexible strip, as you can see, and so you can attach that to some things or find many creative ways to use them. So that's my pick of the week, is these ultra skinny NeoPixels, and they are, I believe they might be out of stock at the moment. They were the last time I checked, but if you want to go and sign up for an alert, you can get an alert when those come back in stock, and then you'll know. Then you'll be ready. So next thing I'd like to get into is a little something I like to call the MakeCode Minute. right, so let me get set up here for our MakeCode Minute by bringing up my Chrome browser. The thing I'd like to talk about today in the MakeCode Minute is the new Pixel sprite editor and animation editor, as well as animations, motion animations that are available inside of MakeCode Arcade Beta. So first of all, I'll show you. I've got a little demo here, and if I go full screen on here, you can see I've got some little Happy Halloween stuff going on, little cycling animations. I have a bat in the middle that I can control with my keys, so he just flew away. Let's bring him back. You can do these little, called parachute left, parachute right, ease up. If I hit A, he goes to the center of the screen. And I also have a little bonus thing here where if I hold down the B button, I get an alternate screen, and we can see the little ghost who's been saying boo there. So how do we do this? We could do these sorts of things before in MakeCode, although it would have been pretty difficult to do those motion animations with that type of ease in and ease out. So if you look at the sprite editor, there's a lot of new features. I won't go over them all, but the key feature is we can now zoom in the sprite editor, and this will make your life so much easier when you are creating your artwork. The other thing that has changed is the animation system is now much more simple. You can see here, this is my little function full of the animations, and if I look at one of these, it looks just like the sprite editor, but now we have frames of animation over here on the right, so I can duplicate those to add more frames. We also have a marquee selection tool now, so I can move things around and go in here. Let's change the eyes to pink. How about? And that will now create a third frame of animation, and I can preview it right here. So if I hit play, I can see my little animation going on. Hit stop there. And the third thing I wanted to show is these motion animations. So right in the animation extension section, there is a animate, and then it says with fly to center as the default. And you get a drop down here with a whole bunch of different options of shaking and bouncing and easing in and out and parachuting. You can also control the timing and whether they loop or just play one time through. So go check those out. I'm really excited about it. It is the new sprite editor, animation editor, and motion animations inside of MakeCode Arcade Beta. And that is your MakeCode Minute. Yes, indeed. Hey, where'd I go? There I am. By the way, if you're interested in chatting with people during this show, there's a couple of particularly good places. The YouTube chat, we have some people there, and the Discord, the Adafruit Discord. So go check out either of those. I know there's people viewing on Twitch and Facebook and some other places, but we don't keep our eyes on all chats at once, so those are the central areas. And I'd like to say to Joachim Hummel over in the YouTube chat, Dankeschön. He liked my Klangforschung shirt here from Dopfer. It means sound research, I believe. Dopfer makes synthesizers. Craig Ritu was asking, what's the width on that bad boy? I think the bad boy you're referring to may be the NeoPixel strips. Maybe clarify, but it's a 0.5 meter is the length of this strip. And I don't know, you'd have to check the product page to see the size of these, but they might be a millimeter square or something like that. They're pretty tiny. And what else? What else have we got? I think it's time to look at the MakeCode Arcade Game of the Week. So let's bring back this little Chrome browser, and I'm going to swap over to my pick of the week, which is called Bunny Hop, and it's by Shack Attack 8, who has been featured here before, writing some great games. Thank you for continuing to bring these out into the community for people to play and to look at. So first of all, as I like to do, let's take a look at the game itself. This is a jumping platformer game using this little bunny, and it is very difficult, so I will die pretty quickly, I'm sure, but let's give it a try. Let's hit A here if I can. I think it's arrow keys. All right. Oh, and I've fallen and I die. So I died really quickly. So the thing I really thought was terrific, there's a lot that's great about this game, but the thing that I'd like to point out here is you'll notice we have this lava that is kind of raising up as we go. And if you don't keep bouncing, you die in the lava. Take a look at how this was done. Here is the gallery. And in fact, I'm not in beta of MakeCode Arcade, so I'm not able to scroll that. Drat. But if you look at this is the tile map. And this tile map is what creates the game level. Sometimes you can use these straight colors for the graphics. Sometimes you can put tile maps on them. And you'll notice this is the set of platforms I can jump on are these green dots. These yellow coins or carrots are the food in the game. And then we have a single line of lava down here at the bottom to begin with. What happens to make that raise is really clever. It's this block right here, which says on-game update every 1,000 milliseconds, so every second. Draw a line in picture from x of 1, so the far left, and y of whatever the lava y value is, which probably starts at 1, to 8, and that same lava y value. Then change that lava y value by -1. So the coordinate system of this game starts at the top at 0. So every time we subtract 1 from whatever that initial value is, we move that lava up by 1. And so that's how every second the peril continues to increase and the lava raises up, which I thought was fantastic. So great job, Shack Attack 8. Please go check out Bunny Hop. You can go to forum.makecode.com and you'll find a link there, and I'll also put it in a blog post a little later on. So that is my MakeCode Arcade Game of the Week. And now, the moment I've been waiting for is the project build. So for the project build today, this is going to be focusing on our brand spanking new, I think we even say it's in alpha, but this is our brand new board. In fact, let me show it off up close here. This is a very familiar looking circuit playground style board. But you'll notice we've got our blue fruit logo there, we've got our blue solder mask, and there's a little addition here, which is this blue fruit logo and a blue fruit antenna. And the chip that it's running on is the NRF 52840, which is a Nordic semiconductor chip that is all the Bluetooth stuff we need as well, or Bluetooth LE stuff we need, as well as a Cortex M4 chip. I believe it's Cortex M4 chip architecture there. So this board really ups the ante of the stuff that you can do with a circuit playground, in my opinion, because we can now use the circuit playground Blue Fruit as a remote control. We can use it as a beacon. We can use it to send and receive sensor data. It can be a client. It can be a peripheral. It can be a server. It can be a what's the other word I'm looking for? I forget now. I forget all my Bluetooth terminology, or I never knew much of it to begin with. But I'm excited to be learning it as we go and use these projects. So the first thing I'll show you with this, in fact, let's go over to, yeah, I'll do it right here. So let me give this one power. And I'm running Circuit Python on here. And we've got some hot off the press Circuit Python libraries and a build of Circuit Python for this board that allow us to do things like use the phone and our Blue Fruit app to talk to the board. So what I'll do is I'm going to fire up the Blue Fruit app, and I'll put that right here for a second. And you'll see there's a device broadcasting itself, Circuit Pi device here. And what we do in this app is we filter out stuff that doesn't have UART. So I'm not seeing the bazillion other Blue Fruit things that are in the area, just things that I can connect to. So when I connect to this board, what I should be able to do with this one, thanks to the code that I have running on here, is head to our controller and go to the color picker and send color picker data, which is very cool. And you've seen us do this before with other microcontrollers and separate off-board NeoPixels, and a lot of you have done projects with these, which can be a lot of fun. But a couple new things here. One, I'm getting to use the Circuit Playground Express, which has all this onboard stuff. So I'll be able to send accelerometer data, and I'll be able to use onboard NeoPixels, and I'll be able to read analog input data, and so on, the buttons, the sliders. But what's also really pretty exciting here is I don't need the app. So I can now use multiple Circuit Playground Bluefruit boards to talk to each other. So what I'll do is let's head over to the bench, and I will show you some examples of Circuit Playground boards talking to each other with no computer or mobile device, iPhone, iPad, Android device necessary. So move my goose. What I have here is a similar configuration. Zoom down here for a little bit. There you go. I have a similar configuration here to what you just saw. So this board is going to act as a peripheral, and this board is going to act as a central, which normally would be your phone. I'll plug this in. Now this board, you can see, has got a bunch of extra jazz on it, and that is because I've attached 3 slide potentiometers. So I built a little board here that I have 3 slide pots, but this could be regular rotary potentiometers or any other analog sensor you want in this configuration. And so what has happened is these two have immediately communicated with each other. So this board is broadcasting out or sending out commands that this one is listening for and receiving. And so you can see I've got some colored pixels on there. Go even a little closer. And the color of those is determined by these 3 sliders that I have. So I can cut the red out, and now it's mostly blue. I can push that blue up even more saturated. Pull that down all the way. And so what we're doing is every time we broadcast, we're sort of telling another pixel to light up until we reach the full circle. Which also means I can do fun things like this and bring in other colors in that little pattern there. And so these represent red, green, and blue. So there's fully red slider, fully green, and fully blue. And that's pretty darn exciting, because in the past, what we've needed to do is have a phone involved. And I was actually just talking with Dan Halbert earlier. Dan's one of our creative engineering team developers who's been doing a lot of the great work behind the scenes in CircuitPython to make this stuff work. And he was saying, yeah, you know, I think that there's a lot of cases where people have like a cosplay prop or costume element, just for one example, where they want to be able to maybe have control over something remotely. You don't want any wires connecting stuff, but you also don't necessarily want to have your phone, which tends to look a little bit out of place when you're you know, a giant Mothra walking around. And so the ability to build kind of whatever inputs you want using a Circuit Playground Bluefruit, and then I have another one on the receiving end that's connected up to making sound, motion, lights, what have you. This is, I think, a real huge step forward for the types of projects that people are going to build. The things that will probably, the questions that will probably come up for things like this is things like pairing and security and low power modes. And so these are all things that are in the work. This is really brand new. But I was talking to Dan, and he was saying, yeah, I think we have in some demo forms currently, but we'll have things like pairing, where you have 2 devices sort of sharing a key and becoming a secure pairing, kind of like how your keyboard works with your computer, or your headphones work with your phone, or your phone works with your car. And you know, another thing you'll find when people want to do sensors is they might want to have one of these out somewhere plugged into a battery, or maybe even some sort of solar setup, and they want it to be very, very low power. And so something we don't have now, but again, we probably will be working on, is some sort of sleep mode type of thing, which you'll find with some devices like a little tile. I have some of these tile devices that are beacons that let you find your keys when you lose them. They essentially wake up every 10 seconds and send out a little ping saying, here's my location, and then they go back to sleep. So those are things that'll be coming. But right now, I'm really excited that we have just this working. What I like to do is actually show you what the code looks like for this, because another thing I was talking to Dan about is that when I've done things like this before in the past, it's been pretty tricky code to do the setup. I've used some libraries in Arduino with the radio frequency, the RFM and LoRa, and it's not straightforward to use the code, at least for a hack non-coder like me. So what I'm excited about here is the simplicity. If we take a look, here is, let me bring up my Moo. So essentially on the circuit playground Bluefruits, I have some libraries, and you can see in this case I'm using, let's see, this is the client, so this is the one that has the sliders on it. This one is using this Adafruit Bluefruit Connect library, and it's using this Adafruit BLE library, and then some of the functions within those. This one has code to read some analog inputs, so I've got my 3 slide potentiometers just plugged into 3 of the analog inputs, as well as power and ground for reference, acting as voltage dividers. And then in the code here, this is it. Like this is all the code there is. So we are setting up the connection with the other device, and then when we are connected to the other device, when it has done the little, hey, yeah, I'm here, I exist, so it's sort of sending out a little ping to say, yes, you're connected to something, then we generate these little variables for red, green, and blue just based on whatever the current values are on those sliders. And then we send those out. So we create this packet that has that set of values inside of it, RGB values. And then we write over UART to the receiving device, and then continue. And we take a little break for every third of a second. On the receiving side, you can see it's almost simpler because we don't have any of that analog input stuff. All we do is we set up some NeoPixels on this one, and you could use external NeoPixels. These would be external strips. I used the onboard one. So you'll see that we have the board.neopixel, and that calls the onboard one. But if we said board.d1, we could have a NeoPixel strip attached to the d1. Is there a d1 on these? I can't remember. But you could attach a strip to an available I/O pin. And then we, again, are receiving this connection from the UART server. So this one is serving it up. And then reading that packet and pulling out the red, green, and blue values, and that's what then goes and tells the pixel, the next pixel in the row. And then it just uses this modulo number of pixels to get to the next number and loop back to the first one. So I love how straightforward that is, and as you can imagine, switching out what the inputs are on the one side and what the end result is on the other side is somewhat straightforward. So if you're doing things like driving, let's say, a servo motor, you might just be taking a potentiometer on one side and remapping that analog value set to some range of degrees on a servo motor, and then on the other end you're just receiving whatever that packet is and moving your servo. So there's a ton that you can do with this. One other thing I wanted to show, because I mentioned the UART. In fact, we'll go back over to the bench cam for this. Oh, did that camera just died. Let's turn that camera off and on, pardon me. It is still hot in Southern California, in case you were wondering. Still hot enough to cause my poor aged camera to shut itself off. Let's see if that was long enough. It's back. All right. Is it? Hello? There you are. All right, we'll see how long that stays on. Let's go here. So yeah, the other thing I wanted to show you, and I'll use an iPad for this just because it's bigger and be able to see it a little better. is, I hope it's this one. Yeah, I think it's this one. So on this one, and I'll show you the code in a second, this one, you're not going to see it do much of anything, but what we will see is on the iPad, and I'm just going to unplug my other ones so that I don't play a little game of trying to figure out who's who. Got lots of these to unplug. Let's see. That's not possible. Let's see, I think it's this one. I guess it's that one. So I think this is the one I've just connected to. We have a UART, which is essentially a serial connection without wires. So imagine the types of commands that you could send back and forth could be simple little serial commands where you usually plug into TX and RX between two boards. Here, what I'll do is I'll say hello, and what happened is, I'll raise this up, it might go out of focus. It definitely is out of focus, but what you may see here is I typed hello, and then below it is the echo. So that means that the UART string went to this one, and the code on here tells it to then ping that back. So what this means is you can actually set up your code so that you can type commands in here. You could type in the letter A, for example, send it, and have this one change to a color, and B does another one. So this simple test just has it echoing back and forth, but the interesting thing is that you can use this to have text feedback. And I've actually used this, this as the foundation for some escape room stuff before, where I needed to know an item that had been manipulated by one of the players come back and show me on the screen here. So if you look at, I'll open this up in Moo. So let's switch back over to, there's Moo, there's me, that. This is one of the pieces of example code that we have. And the question is, where did I put it? I think it's right here. Oh, no, that's not it. Hold on, stand by. Examples, there they are. UART echo. Okay, I can zoom in here so you can see that a little better. So this one uses the UART, or the BLE library, and it uses the UART server code from that. It establishes or instantiates a UART server. It advertises itself so that it can be found by my Adafruit app on the iPad when it looks to see who can I connect to. This one is showing up because it's advertising. And then it waits to be connected, and once it is connected, it will read a byte that's incoming, and if it does get a byte, then it writes it right back out. And so we can then do other things in code, like say, look at the byte that came and say, oh, if that byte was A, then we'll change some neopixels to a certain color, or we'll send back the reading on a sensor. So I hope this helps you understand a little bit the relative simplicity with which we'll be able to do these types of remote connection things. And hopefully that'll inspire some very cool projects. So we're all just getting started on these, but there's a lot of exciting stuff we can do. You might have seen Scott Shawcroft has done some proximity-based things already. So when these devices are broadcasting, they are also, you can read the power of the signal, and so you can do things where whichever, if you have multiple of these devices, whichever one you're closest to, you'll get data from that one, such as I'll turn red when I'm near the red one, I'll turn blue when I'm near the blue one. So there's some interesting stuff there as well that I haven't looked at here yet. So that wraps up our project of the week, which is our Circuit Playground Bluefruit Color Remote. And I will, on the way out, remind you that your coupon code this week is pancakes. And pancakes will get you 10% off in the Adafruit store. So head on over there and load up on cool stuff. You might even get some Circuit Playground Blue Fruits if they're available. I think they may be, but if not, set up an alert for yourself and you'll get an email when they are. And then with that, I will say goodbye. Thank you so much for stopping in. This has been John Park's workshop for Adafruit Industries. See you next time.